So what I'm going to do is talk about, even though this is a sponsored presentation, I'm not going to talk about the product or anything like that. I'm going to focus in on basically areas around SDN, where things are going, and where security specifically fits into that. And I'm going to use 5G, even though it's in the standards bodies right now, it's still taking a long time to get through. The plan is to have something out theoretically by 2020. That's the timeline for 5G. But what you're finding is that number of carriers are already moving towards 5G as a deployment. And what I'm going to do is tie that back to how a virtual environment needs security, and specifically where DDoS fits into all of that. Okay, maybe this way. Okay, so what does a typical service provider network look like today? And most of you guys should be aware of this already. Typically, you have an access edge, pre-ag aggregation points, a transport core, and centralized services deployments. So most carrier networks, whether they're AT&T, Vodafone, DT, I can sort of list a range of carrier networks here, will have some sort of layers of network homologation or connectivity, and all their services typically sit in a centralized area. So whether they're in the previous presentation, you talked about avoiding NAT services, or even mobile layer 3 or layer 4 service examples, or even DPI, those types of services sit in a complex or a services complex or that type of environment. Now what's happening in that environment, and security is an afterthought in all of those networks. All right? If you look at any sort of carrier deployment today, whether it's 4G, the previous 3G, or even as you move slightly further forward, security has always been, okay, so I may put some firewalls into my services environment or in my services gateways, or I may decide to, I'll stick something, I use CGNAT as a security mechanism. Some carriers actually think about it from that perspective as well. Or I'll do some level encryption on the signaling layer. It's always been an afterthought. The problem is that once you start moving to the next generation architecture, you can't think about security as an afterthought. You can't think of it as a specific overlay environment. You have to start thinking about it built in from day one in your architecture and your network. So this is an example of what today's 4G network looks like. Slightly complicated. It should have been a simple deployment from 3G to 4G. It should have been, the idea was to simplify the whole thing. So you have things like, charging systems, you have PCRF, you have 3G, you have AAA services, you have Wi-Fi connectivity, the trusted or untrusted, those types of environment. Where does security fit into this, right? So maybe I'll stick a firewall right at the sort of the MME entry point into the network. Or maybe on the internet-facing side of it, I may have theoretically some sort of DDoS, all right? Or maybe on the edge of the mobile environment, I may do some sort of encryption on the control plane or the signaling plane. The problem with that type of overlay environment is that you put the network in its place, you put all the services in, and then you start thinking about where should I put security into this. We have customers, or we're looking at a customer in Germany, for example, that have decided, okay, I need to put DDoS in now. What they've typically done is they've had a scrubbing environment. They will throw traffic into the network, they'll see some sort of anomaly, they'll swing the traffic, they'll clean it, and they put it back. The problem is that once you start putting start putting subscribers on the edge of the network, so you start putting enterprises on this left-hand side of this network, and then you start thinking, okay, and I get a small DDoS attack, what the impact to that customer and the impact to all the customers that hang off that radio tower means that they all go down at that point. A small DDoS attack propagating through this network, as far as this environment is concerned, or as far as a typical carrier network is concerned, a small DDoS attack looks like noise on their network. It will work its way through the environment. It will then take down all the subscribers on the left-hand side. It will take down that radio network, and it will also take down any enterprises that sit off on a permanent IP address or a static IP address on that side of the network. So that's an impact of a very small DDoS attack on that. And what we're doing, and what they're looking at doing, is putting something in line to try and stop that. So that's just an afterthought from, the customer happens to be DT. That's the afterthought they've looked at, and we need to do something to stop that. Now what happens when this network starts slowly morphing to a 5G environment? So as I said, security has always been, even if you go through the 3GPP specs, and I spent a lot of time looking at the specifications for 3GPP, it's a sort of an afterthought in terms of where they put in security. Should I do encryption? Should I not encrypt my traffic? Should I put in some firewalls in various locations? It's actually not the way you should be thinking about this as you go towards a 5G environment. Now, I understand that 5G environments are still sort of being worked out at the moment, but what I want to do is propose that this is sort of where 5G is going, and this is where most carrier networks over time are headed. It's moving away from the centralized transport architecture which most carriers are put in. So if you look at AT&T, for example, their current environment has always been centralized core, and I'll use it as a transport service for all my subscribers that are being attached to it, whether they're UVerse subscribers or whether they're mobile subscribers or whether they're cable subscribers. They're now moving towards this. So if you've ever read the domain 2 architecture, it's more towards server-centric, server virtualized environments. So typically, what does a security environment look like in a cloud-based world as opposed to a transport world? And that's what the 5G group is now looking at, and the 5G specifications are looking at. And what is a next-generation architecture in terms of its capability to elastically scale, elastically grow, and the number of services that you want to apply. So think of it from that perspective. Don't think of it as I'm creating a network and I need to move packets across that network. It's now, I have a set of services, I want to slice and dice my environment, and I want to deliver a particular service. So whether it's IoT or whether it's IoT for a car, or that level of communication and that level of data analytics, I have to be able to slice my 5G environment and provide that level of subscriber service. That's the rationale behind where 5G is headed and where most service provider next generation architectures are going. They're looking at a centralized optical transport network, and they're looking at shifting all of their services to the edge. So if I happen to be running mobile-centric services in Canada, and I have a particular subscriber base in that requires particular video services, I will create my environment to serve that particular customer base. So if you look at what even Vodafone and BT are doing, that's basically where they're headed. So let me give you an example of what the idea behind 5G is. The idea behind 5G is it's around, they talk about it from an SDN perspective, but think of it as a virtual environment where I can deploy specific services wherever I need that particular level of concentration. So if I'm looking at, typically most 5G networks have a centralized EPC core, for example. That will be virtualized and that will be placed fundamentally where the subscriber is going to be, wants that level of connectivity. So in the previous presentation, we talked about Wi-Fi services. That's either untrusted or untrusted network on most carrier networks or most mobile networks. That will also shift to where those subscribers require that service. Now, the problem is, how do you then drive security across that environment? Even if you start looking at the 5G specifications, they don't necessarily talk about security. They talk about it from the perspective of, I need to virtualize a whole bunch of functions. They exist on the mobile network, or they'll exist on a bunch of servers. I will elastically scale these servers up, and then I'll generate, and they'll create a slice model across their network, and I will put that into my network, and everything will work fine. And maybe I'll do some firewalling. That's literally what the 5G specification starts talking about. What we're proposing is that whether you do virtual EPC, or whether you offer GI LAN services, or whether you offer any sort of services environment in a cloud-based world, you have to think about security from day one. You have to think about DDoS, you have to think about malware services, you have to think about virtualized firewall services. You have to think about building in security from day one in that environment. And specifically, the reason why you need to do that is that from our perspective, or from Corero's perspective, we see attacks, DDoS attacks occur on a regular basis. We see the very large volumetric attacks, the 300 gig, the 200 gig attacks. But what we're seeing every day, every hour, is these low-level attacks that typically rise to about 2 gig or less. They last about 5 minutes, they propagate through your network, and they impact every application or services server down the link. If you have a firewall sitting there and you see this type of attack coming in, it will literally fail the firewall, it'll fail your IPS, and then it will impact your servers at the NIC level and all the way up and down the stack. So from our perspective, you have to build in some sort of layered security mechanism inside your architecture. And if you think about where the next generation service provider architecture is now going, it's a cloud-based environment. It will be deploying specific services at the edge of the network, depending on how you define your edge, and then it will be completely virtualized, or to some extent virtualized. If you follow AT&T's example, every service they want to offer, every environment they want to look at, it will be a virtualized. Whether it's a Juniper MX platform or a Cisco ASR9K, they're looking at virtualizing that. If you virtualize your router environment, you virtualize your control and data planes. If I give you a low-level DDoS attack in that environment, it will take down those routers. Your signaling and control plane drops. All your subscriber services drop at that point. In that type of environment, even though you're providing a localized service for that particular subscriber base, it's not going to stop these types of attacks. So our proposal is that you build security in from day one. You look at low-level attacks, you look at inline deployments, and then you also look at the level of visibility that you can provide to find out exactly what's occurring across that network. And sort of the last thing I want to specifically talk about is tying that back to the 5G environment. There'll be the idea behind 5G is you have lots and lots of devices attached to the network. These devices are a mechanism to generate attacks. You can take over these devices. They have an IP address, whether it's v4 or whether it's v6, whether it's NATed or not. You can take these devices and you can use them as a mechanism to get into the network, right? So the idea is you have to provide a level of protection and a particular level of security across all of this. And from our perspective, because it's a virtualized environment that you're now headed towards, because the next generation architecture has to cope with this type of environment and everything will be connected, it's a right mechanism to generate attacks into the network, whether they're DDoS attacks, whether they're attacks to pull data off the network. It's that type of architecture that you now need to be thinking about. Any questions or specifically around where the next generation network and where DDoS security inherently fits into that?
How would you propose that the type of security you're envisaging would work across domains where you need to interwork with other operators as well as working within your own domain?
So if you look at it so typically what we do is we sit at the peering point or the transit point of the network. So whether it's an inter-carrier transit point or it's a transit link across that network, and there's one of two options. You can either scrub that traffic or you can run inline. We typically sit in line and we look at the streams coming inbound. And what we found in the networks that we've deployed in is that most of that traffic goes downstream and it gets impacted. So if you have a tier 1 transit link from level 3, for example, all that traffic comes working its way down and will typically hit a tier 2 or tier 3 carrier that's providing that or was looking for that connection. Our perspective is you sit in line and look at that traffic and clean that traffic as it's coming through in line. It gives you two benefits. It provides maximum visibility about everything that's going on. You can also look at inter-domain traffic at that point, but it also provides you the ability to clean low-level attacks, which we see on a regular basis. Does that help to answer the question? Any other?
Hi, Piers O'Hanlon. I was just wondering about what you're doing about the sort of increasing level of encryption of a lot of traffic. I mean, it's sort of 50% now, and it's headed sort of upwards from there. I mean, do you do sort of sharing of encryption kind of material with the security infrastructure to do the DDoS stuff, or do you do it on encrypted traffic? How does that work? So typically what we found is that at the peering point of the network, you're looking at volumetric or reflective attacks. So what we're proposing is you have a tiered security architecture or a tiered DDoS architecture. At the edge of the network, you clean out all the volumetric attacks and reflective and amplification attacks. Those attacks typically are not encrypted.
As you get closer to the web tier, the data services, that's where you're going to see SSL traffic, and you're going to see encrypted attacks coming in, and you have a trusted relationship with the keys and the key generation environment at that point. Most service providers, from almost carriers that I've seen, typically won't share their keys further out, and they're looking at it from, so the net of it is you're never going to have one device that's going to take volumetric and SSL type environments. The problem with that type of architecture is that those two they tend to oppose one another. When you're looking at pure application encrypted attacks, they don't tend to work very well with a volumetric environment. So you're going to end up having multiple systems to do this. And the secondary system may just be completely virtualized. So it may just sit right at the hypervisor layer. It has an internal decryption mechanism. You clean out that traffic at the application or that specific service layer, and then you ramp it back into that service. There are proposals out there where to handle this type of environment, you literally have a DDoS environment or a security environment on a service-by-service basis. So if you have a particular application that's running, you run your security environment just to cope with that environment. If you look at what AT&T is doing, or even Vodafone, for example, they're looking at that type of architecture where you clean out the bulk of the traffic at the edge of the network, and then you have a particular application or a particular service mechanism that looks at just that application and looks at all the security threats to that application, and you run that directly in the hypervisor effectively.
Thanks.
And obviously the two things that need to talk to one another.
Okay, thank you, Bipin.
Thank you, Ryan.